This pan looks completely harmless. It saves your breakfast, makes your eggs slide like magic, and rescues you from scrubbing burnt residue for 20 minutes. But beneath this smooth exterior lies an uncomfortable question. What actually happens when this perfect surface gets scratched, overheated, or begins peeling directly into the food you are preparing to eat? Because a nonstick pan is not just metal. The slippery surface is a fluorinated coating, and under the wrong conditions, it can release elements you do not want in your kitchen. The truth is more complex than simple catchphrases. Today, we answer, is your pan releasing chemicals? And when should you actually worry? Most people assume the primary danger is the black coating itself. We picture tiny, dark flakes of nonstick material chipping off and mixing into our food. While that can certainly happen if a pan is scratched or heavily damaged, the actual, more significant risk may not be what you swallow. It might be what you breathe. When certain nonstick coatings are heated too high, they degrade and release invisible fumes. These fumes are linked to a short-term illness called polymer fume fever, or Teflon flu, with symptoms like fever, chills, coughing, fatigue, and headaches. In 2023, U.S. poison centers recorded 267 suspected cases, the highest since 2000, though some stem from workplace settings. What turns a standard pan into an active chemical exposure risk? To truly understand this risk, we have to look at the science of the pan itself. Most traditional nonstick cookware relies on a polymer coating called PTFE, short for polytetrafluoroethylene. You likely know it best by the brand name Teflon. PTFE is incredibly slippery, highly heat-resistant, and chemically stable under normal cooking temperatures. Under ordinary conditions, this stable structure is exactly why eggs slide around like magic. But why does this material behave this way? And what happens when those stable chemical bonds are pushed beyond their ordinary limits? PTFE belongs to the broader world of fluorinated compounds. Many of these are connected to a class of synthetic substances known as PFAS, or forever chemicals. This nickname highlights their extreme persistence. They do not degrade easily, lasting in our environment for vast periods. According to the ATSDR, these man-made chemicals have been used globally since the 1940s, are found at low levels in foods and ecosystems, and can accumulate in our bodies over time. This accumulation over repeated long-term exposure is exactly why scientists and health agencies closely monitor their presence in consumer products. When shopping for cookware, you have likely noticed prominent labels reading PFOA-Free. While this sounds deeply reassuring, what does it actually mean? PFOA is a specific chemical historically used to manufacture certain PTFE products. It became a point of major concern due to its longevity and potential health effects. However, PFOA-free does not automatically mean a pan is PFAS-free. It can still utilize PTFE or other fluorinated materials. This subtle distinction confuses many consumers. A pan can be PFOA-free, yet remain a standard PTFE nonstick pan. To address these concerns, in 2006, the U.S. Environmental Protection Agency invited 8 major companies to join a stewardship program. The goal was a 95% reduction in PFOA emissions and product content by 2010, aiming for complete elimination by 2015. The EPA states that the manufacture and import of PFOA have been phased out in the United States under this program, though existing older stocks or certain imported items might still contain traces. This history brings us to the biggest daily mistake people make in the kitchen: preheating an empty nonstick pan on high heat. If you are used to cooking with heavy stainless steel or seasoned cast iron, preheating feels like second nature. But doing this with PTFE-based nonstick pans can be highly risky. Without food or liquid to absorb the thermal energy, an empty pan heats up incredibly fast, reaching extreme temperatures much sooner than most home cooks expect. This rapid spike is where the chemical stability of the polymer starts to rapidly break down. At normal cooking temperatures, the nonstick coating remains completely stable. However, when temperature climbs too high, the material degrades and releases fumes. Toxicology experts and consumer health reporting place this critical danger zone around 500 degrees Fahrenheit, or about 260 degrees Celsius. This happens easily when a pan is overheated or left completely dry on a hot burner. You cannot see or smell these fumes, but hours later, exposure can trigger polymer fume fever. For healthy adults, the chills, fever, cough, and fatigue usually clear in a day or two, but those with heart or lung conditions are more vulnerable. But heat is only half of the story. The other major hazard is physical damage. Using metal utensils, stacking pans unprotected, or scrubbing with rough pads wears down the nonstick coating. When damaged, particles flake off. A 2022 study highlighted in Health Reporting found that scratched PTFE pans can release thousands to millions of microplastics and nanoplastics into food. This particle release is significantly higher when the cookware is actively worn, peeling, scratched, or subjected to high temperatures. This means that a physically compromised pan represents a continuous source of degraded material entering your meals. Now, let us be realistic. One tiny scratch will not instantly poison you. Suggesting so would be an exaggeration, especially since science is still developing on what these ingested microparticles do inside the human body. But from a practical safety standpoint, the advice is simple. A scratched, peeling, or flaking nonstick pan is no longer performing its job. If the coating is physically breaking off, it is time to replace the pan. Not because a single flake is toxic, but because the material has reached a stage of ongoing degradation. Why are scientists so deeply concerned about the broader family of PFAS? It is because these chemicals are highly persistent, widespread, and increasingly associated with long-term health risks. The EPA notes that peer-reviewed studies associate certain levels of PFAS exposure with reproductive and developmental effects, hormone interference, reduced immune response, and elevated cholesterol, alongside increased risks of some cancers. The ATSDR also points to potential associations with liver enzyme changes, pregnancy-induced hypertension, preeclampsia, lower vaccine antibody response, and kidney and testicular cancers. These findings have triggered massive regulatory investigations worldwide to trace how these compounds enter our daily environment. However, we must make an important scientific distinction. Most of this health research is not focused on an occasional omelet cooked in a nonstick pan. The primary concerns about PFAS exposure stem from contaminated drinking water, industrial emissions, food packaging, and communities living near production sites. We should avoid overstating the direct danger from cookware alone. While your nonstick pan is likely not your largest source of daily PFAS exposure, it is one exposure pathway you can completely control. And in a world full of complex environmental variables, having direct control over what enters your immediate kitchen environment is incredibly empowering. To keep your cooking safe, follow these 5 essential rules. First, never preheat a nonstick pan empty. Always add food, oil, or butter beforehand to keep temperature under control. Second, stick strictly to low or medium heat. Third, use wood, silicone, or soft utensils, as metal will scratch the coating. Fourth, replace the pan immediately if the surface shows bubbling, peeling, or deep scratches. Finally, ensure your kitchen is well ventilated. If you own pet birds, be especially cautious. Toxicology reports warn that birds are highly sensitive to PTFE fumes. A simple slip in temperature can cause severe, sudden harm to avian respiratory systems. Should you throw away your nonstick pans today? Not necessarily. Used correctly, they remain highly convenient tools. But if you want to reduce your reliance on fluorinated coatings, excellent alternatives exist. Stainless steel is unmatched for browning and sauces. Cast iron offers a naturally low-stick surface when seasoned properly, while carbon steel is lighter and perfect for high heat. Ceramic-coated pans avoid PTFE entirely, though they can wear out faster. Ultimately, there is no single perfect pan. The secret is using the right tool for the right cooking task. Keep nonstick for eggs and save the cast iron for high-heat searing. Ultimately, your kitchen's safety is not about fearing your tools, but understanding them. Nonstick pans are not inherently toxic enemies. They are specialized utensils that demand mindful, low-temperature habits. By adjusting how we heat, stir, and maintain our cookware, we can easily minimize chemical risks while keeping our cooking effortless. If this made you look at your kitchen differently, subscribe to Curious Lab. Next, we investigate another everyday object releasing invisible particles into your food, your plastic cutting board.